Hi everyone, welcome to this session on client-side field-level encryption. My name is Matt Keep and I'm going to be talking you through what client-side FLE does. I'm part of the product team here at MongoDB and I'm delighted to be joined by Ken White. Hi Ken.
Thank you, Matt. Hi everyone, thank you for joining us today. I'm Ken White, Security Principal here at MongoDB. I work on applied encryption for our global product group and I'm Product Security Lead for our client-side field-level encryption product. Today for the session, we're going to take an overview of FLE, take a look at some of the design goals, and then we'll get deeper into the implementation and data flows of the system. And so with that, let me turn it back to you, Matt.
Great, thanks. So before we get too far into the detail, let's level set on the design goal of client-side FLE. It's about providing the strongest levels of data privacy and security for regulated workloads. And what you're going to learn during the course of this session is how client-side FLE provides end-to-end protection of your most sensitive data by encrypting and protecting data in use in memory. We'll show you how it will increase your confidence in moving to managed services in the cloud. And then finally, how it simplifies your compliance with modern privacy regulations, specifically right to erasure, sometimes called right to be forgotten. So in terms of the agenda, we'll talk about encryption today, both its strengths and its gaps. We'll then move into the implementation of client-side FLE, and Ken will spend some time going through that implementation and how you can get started with it. We'll then move on to address some of the most frequently asked questions that come up from developers and InfoSec teams when we talk to them about client-side FLE, and we'll wrap up with some case studies. So we'll look at who is using it and for what. So encryption is proven and trusted, right? In commercial computing, encryption has been around for close to 60 years, but there are gaps. So when we think about moving and storing data, most databases have that covered. So as we're moving data from our application into the database or between replicas of a distributed database, we can encrypt data while it's in flight over the network using TLS encryption. But as soon as data hits server memory, it's decrypted so it can be processed by the database. When it comes to storing data, as we push it down onto disk and into backups, we can use things like volume encryption or storage engine encryption so that we can protect data at rest. But again, as that data is paged off of disk back into server memory, it's decrypted so it can be processed by the database. So hopefully what you're seeing here is a little bit of a gap. What about here while data is in use, in memory, in an active database instance? In that instance, data, while it's in memory, is in plain text, which means it's vulnerable to insider access and active database breaches that can come from both authorized and compromised admins and users, and also more sophisticated exploits like RAM scraping and process inspection. So you can ask, well, how much of a risk is this really? So if we turn to the Verizon Data Breach Investigations report, and this is a report that's been published every year since 2008. It looks at thousands of security instances year on year. It's really one of the most credible and comprehensive guides that's published in the space of security and data breaches. Some stats that aren't actually shown on this slide, but in their most recent report, they found that over 50% of all breaches are now specifically targeting personal data, so PII and PHI, and that represents a 2x growth year on year. So that's the real gold that attackers are going for. Now, when it comes to the kind of different types of attacks, we can see through the Verizon research that 55% of all breaches are committed by organized criminal groups, including state actors. So these are sophisticated breaches. 37% of breaches use stolen credentials to access secure systems. So as far as the system was concerned, it was dealing with an authenticated and authorized user. And just under a third of all breaches were committed by internal users. And that's actually a pretty low ball number. You can find plenty of research out online where insider breaches actually account for more than 50% of all incidents. So the reality is that yes, this is very much a risk. Now, the challenge is that no database offers a standard solution to closing this gap. So what have we had to do? Well, most have turned to techniques like application level encryption. And what that does is that it encrypts sensitive fields in the application before it's even sent to the database. So here we've got a very simple health record for Pat Lee. There are 3 PII fields in there, the SSN, the email, and the mobile number. So we go from that plain text in the application and we're encrypting it in the application before it gets sent to the database. So all the database sees is ciphertext for those 3 PII fields. So that would seem to solve the problem. But there are challenges with application level encryption. Firstly, it's highly complex. And it's complex because it requires deep coding expertise and cryptographic expertise. It requires developers to rewrite application queries to take on the overhead of key management. And what we've seen is that that adds something like a 50% overhead in development velocity. So it slows down pace of innovation. Similarly, it also limits application functionality. Typically, what you're doing is rendering the data as a blob. The database has no way of knowing what that data is, which is kind of the point. But it means that if you're looking for a specific record by an SSN, for example, you've got to pull the whole database back into your application and decrypt it there. So that dramatically compromises user experience. It requires a lot of additional client-side code and a lot of tuning to achieve acceptable performance levels. So we're really stuck between a rock and a hard place. We can do nothing and take the risk of unencrypted data while it's in use in a live database being exploited, or we can implement application level encryption, which adds a huge amount of complexity and friction to the development process. Client-side FLE gives you a much safer and simpler approach because all you do is select an encryption key, configure the fields to be encrypted in the MongoDB drivers, and you go. Sensitive data never leaves the application without first being encrypted, and the data remains encrypted all the time it's server-side in the database. There's no need to modify your applications. Encrypted data is still queryable, and it imposes minimal performance overhead on both the database and the application. So let's dive into those key capabilities a little bit more before we then get into the implementation. So in terms of key capabilities, firstly, it's totally separated from the database. So sensitive fields, as I mentioned a moment ago, are encrypted by the MongoDB drivers before data leaves the application. It gives you complete protection server-side because data as it's in memory, and then when it's persisted down into logs, to storage, to backups, it remains encrypted. It's inaccessible to administrators. So data can only be decrypted by a party that has client access or that has network access and database access and the encryption key. So it dramatically reduces the surface area of attack. It gives you flexible field level control. You can encrypt a single field, you can encrypt multiple fields of your document or entire documents, and each can be encrypted with their own key. And it's built on industry standard cloud native technologies. So it's using NIST certified AES encryption, which is integrated with the key management services of all of the leading public cloud providers. So when we think about the benefits of client-side FLE, it does three things. It really elevates the protection of sensitive data while it's in memory and in use by the database. So anybody who shouldn't be there can only ever get to see ciphertext, and a hacker would need a whole array of things: the compromised DBA password, network access to the database, and stolen encryption keys to see any protected data. It enforces a separation of duties, which overcomes a key objection in moving to managed services in the cloud. And that's because those who manage the database or the underlying cloud infrastructure don't have client access or the encryption keys. And it enables this compliance with right to erasure or right to be forgotten mandates, which are common in most modern privacy regulations with things like the GDPR and CCPA and many others that have emerged over the past couple of years. So you could ask, well, what's so hard about right to erasure? If a user decides, hey, they don't want to deal with me anymore, I've got to delete all of their data, that's easy to do in the database. But what about data that's been persisted in backups and logs? How do you delete that? There's a real risk of that archived data being restored and used, so you've not actually deleted or erased that user. With client-side FLE, it gives you, again, this safer and simpler approach because you simply destroy the encryption key for the user's data and their PII is rendered unusable and unrecoverable in the database, in backups, in logs, everywhere. And certainly when we go out and talk to InfoSec teams in MongoDB customers, it's this capability that really makes them sit on the edge of their seat. So at this point, I'm going to pass over to Ken, who will take you through how we've done all of this with the implementation in client-side FLE. So Ken, I'll pass over to you.
Thanks, Matt. Yeah, so let's take a look at what this means from a developer's perspective or from an architect's perspective. And then we'll drill in a little bit into kind of some of the specific configurations and kind of the sort of a step-by-step process of how this works, and then some of the mechanics kind of under the hood. So at a high level view, what this what this flow is showing is, let's assume we've got a sensitive application, maybe a healthcare application or something of that sort. So we've got an authenticated user on the left side that has been cleared to access the application. The driver, the developer for the application can simply write a query as they normally would. So let's say we're searching for a particular patient's social security number, or we want their records and we're going to search it by social security number. So in the application, the developer will just write, in the standard, quality match format. So here, DB patients find with this social security number. Now, the interesting thing is that that's what the developer does. What the drivers do when they see that is they say, okay, well, actually, this is on a field level encrypted database. This particular field has been tagged. And so what I'm going to need to do is to encrypt it. First, do I have the key that's been attached to it? If it's already been used recently, it's probably cached in memory. If not, I'm going to go reach out to my key manager. And as Matt said earlier, there's native integration with the big three cloud providers in terms of the key management service. So AWS KMS, Google Cloud KMS, and then Azure Key Vault are integrated. In addition, you can use either in sort of development or sandbox mode, you can just use a simple local key file. You obviously never use that in a production setting, but you can also use something called the local key service, which consumes something like HashiCorp Vault or some other kind of secrets manager. So the driver will request that key, it brings it back, it encrypts the data, it then passes it to the database. So what's actually stored in the database is is that document with those fields that are encrypted. So the database itself never has the keys. It never sees the clear text on those, sensitive records. And it's both from a software perspective as well as infrastructure, and for the people who manage that part of the system, they're never able to see the clear text records. So even in memory, even when you're doing queries or other kind of database operations, they're oblivious to the operators on that side. Now, when you do a query, so we've searched for this particular social security number, the database is asked for that encrypted record, it brings it back, and so the drivers will say, okay, well, now I've got an answer from the database. This looks like an encrypted record. It does the same thing with caching. If it's recently used the key, it'll take access to that. And then what it does is it transparently converts it back to plain text. So what the developer's done is they said, find records with this social. When the driver hands it back, it gets the clear text, plain, original, sort of human readable document. And then hands it back to the application. So the key point of this is that a lot of the mechanics and difficult pieces happen kind of behind the scenes. So from the developer's perspective, it's really powerful because you just use a standard sort of query language. And if you've got an existing suite of application code, in general, you don't have to make any changes or maybe just minor changes depending on the operations you're doing. So let's go next into kind of the step-by-step piece. It's really kind of a pretty straightforward process. There's basically 4 steps. So the first one is you need to identify the fields you want to encrypt. And so the step 1, let's take a look at a document. So let's say this is a sample, patient record or account record or something of that sort. The developer will go in and say, okay, well, these fields, I know they're going to have sensitive data, so I'm going to tag them. Now, we'll get into it a bit deeper in just a second. There's different ways to do it, but in the simplest approach, they're simply tagged explicitly. So security number, email, mobile number, in this case, those are tagged as encrypted. And so whenever the database stores those documents, it's going to ensure that those records are encrypted appropriately. And then so step 2, so we've identified which fields we want. Now we just have to sort of explain to the system how that works. So next we'll generate some field keys. So these are the data encryption keys that are used to actually encrypt individual fields. In a simple case, you can have a single key, for your whole application. In many cases, that's perfectly acceptable. In other cases, you may have people with different levels of access where you don't just want sort of the standard kind of logical implementations, but you want to make sure that that there's no access whatsoever possible. So you may create different keys depending on access level. But in this case, this is sort of a simple example. So we'll just say create key. So in the driver's API and in the Mongo shell, there's now a create key API. You simply call that with some information about the key management. And in the case of AWS, we support both the sort of traditional API credentials as well as the assumed user roles, which are really short-term bearer tokens. So that's a really powerful way to not have to deal with sort of long-term credentials anywhere in your infrastructure, anywhere in your deployment fabric. So we do that. and then we'll fetch those back. In this example, and each key has both a globally unique ID name that's sort of, maybe more familiar to Mongo developers, but you can also put sort of an English friendly, a human friendly name on that as well. In this case, we're just calling it key one. Okay, next we'll set the, now having created the key, now we'll do the JSON types, the data types. Let's drill into this a bit. So as we'll see on the next screen, this is a standard JSON schema specification. And so a lot of folks who develop in MongoDB, they may not be aware that this is a capability, but it's existed for a long time. And historically, we use JSON schema validation to do things like, this field has to be a number, this field has to be a string, this can't be empty, or if this is a number, it's got to be between, 1 and 100 or some other kind of range of values. What we've done, and that sort of capabilities existed in the database for I think going back to the 3 series, the version 3 series of Mongo. What we've done is we've added an additional data type property called encrypt. And so in addition to that, to the other capabilities, you can simply say, here's my field, it's SSN. I want to encrypt it. It's going to be a string, and I'm going to use a particular type of encryption mode. We don't put a burden on the developers to understand anything about encryption or have to get into kind of all the deep mechanics of dozens of different cipher choices or cipher suites or anything like that. In short, there's 2 different approaches. One, if you're uncertain as to the distribution of your data, you'll want to use randomized encryption mode, which is to say that every time a value is created in the database, it'll be encrypted a different way. For many fields, like social security number, like credit card, maybe mobile number, if you were to graph those on a histogram, the graph would be really wide and really flat. That is to say, there's not much predictive value of one person's social security number versus another, or one person's mobile number versus another. And so you'd use what's called deterministic mode, but that allows you to do searches on encrypted data. And so lastly, it's got the key ID that's associated with it. And then so on the next one, we can do some other interesting things. We don't have to hard code the key ID. There's certain operations where we can say, the application user, maybe in a GDPR environment, I've created a data key for each of my app users. And so, as Matt mentioned earlier, with the right to be forgotten context, you want to have a capability where you can just destroy a key, and rather than sort of have to go hunt down through your system all the different places and pockets where that user's information live, you simply destroy their user specific key. But what this also means is that from the application's perspective, you don't need to know that. You can literally say, whatever the user ID that's logged in, if I've created keys who are named by user ID, so user ID 1, user ID 2, et cetera, if each of those is a different key ID, you can do it dynamically. There's some other tricks you can do that take advantage of JSON pointer on the next one. You can do field encryption with JSON wildcards, which is to say, I know I'm probably going to have social and I'll probably have mobile, but I don't know necessarily what my other fields are, either in a top level piece or in a sub document. Whether I have 2 fields or 20 fields, can you just sort of encrypt all of them? Because I don't know what they're going to be. So you can actually do that as well. Now, the restriction is they need to be of the same type. So either all strings, all integers, all longs, et cetera, but you can segregate those by sub documents. Next, and so going back to kind of the 4 steps. So we've identified the fields we want to encrypt. We either do that explicitly or we can do it dynamically. We've created those field keys, or in this case, a field key. We specify the JSON data type, and now we create a Mongo session. And this is the way that you've done it always, right? So in addition to the database, parameters, TLS, LDAP, Kerberos, Scram, federated entity, however you're doing it, we add a couple of different additional parameters. One of them is specifying the key provider, and then the other is this schema that we created earlier. And then we just connect as we normally would. Next. Right, and so in traditional Mongo client connections, you'll just do new Mongo. In this case, if you're just working on a laptop, you could do localhost. We'll just add an additional parameter there that's optional, and if that exists, that's the application's way of telling the system, I'm in FLE mode. Make this an FLE active and encrypted mode session. Okay. And so those are at a glance, those are the 4 steps. We identified the fields we wanted to encrypt. We generate a field key. Now that's typically done at application creation time. We set those JSON data types. We create a new Mongo session as we would with any connection to the database, and then we just run our queries. All right. So let's talk about that for a second, because while it's great to have the database oblivious or kind of blind to the information that's stored there, there's another consideration too. If I have a query that says find all the patient records where the social security number associated with it is this value, the very fact that I'm asking for that data is itself sensitive. I'm not talking about the document itself, but the query in this case is sensitive. The filter in the find statement here is itself PII. And so what does that mean in terms of the way field level encryption works? Well, it turns out we also encrypt queries, right? So as a developer, you say, for example, encrypted database, patients find this plain text social security number. What we actually ask the database for is find all the records that have a field called SSN with this encrypted value. And so that's really powerful. So the database doesn't even know what it is that you're asking. Okay, next. So the queries that are run, the database says, or you've asked the database through the drivers, not the developer itself, but here's the things I'd like to pull, and the driver will transform that back into the clear text. So a really powerful feature for field level encryption. As I mentioned earlier, there's subdocument support as well. So you could say, for example, I've got contacts or addresses with maybe home and work addresses, things like that. We can encrypt those as well. So we'll see in the next slide. We can do both top level fields as well as individual child elements within a subdocument. Or if you'd like, as we show on the next one, you can encrypt an entire subdocument. Right? So lots of options. Now, what does this look like to a DBA? As I mentioned earlier, even with root, even with global cluster admin, even if you own the virtual machine or you're the cloud provider itself, what do you see when you look at these records? You see encrypted data, you see gibberish. When we look at one of these records through Compass, for example, it'll just show stars. That's sort of just a UI thing. But if you hover over that, it'll say this field's encrypted. If you drilled into that, you'll see that this is just binary data that's kind of undecipherable. So really powerful technique. And what that means is that all your traditional application and cluster management tools and so forth continue to work. DBAs can look at query tuning, look at performance analysis, look at all the other information, but things that are logged, if they're encrypted records, they're not going to show up as clear text. Okay. And now with that, I'll turn it back to you, Matt.
Thanks, Ken. Great insight. So where can this be used? You can use this on any version of MongoDB from 4.2 and above. It's supported on the 20 plus supported platforms available for MongoDB with all of our most popular drivers. And you can use it everywhere. You can use it in MongoDB Atlas, which is our fully managed cloud service. You can use it with MongoDB Enterprise Advanced, and you can use it in the free community edition of MongoDB. There is one difference, and that is that Atlas and Enterprise Advanced offer automatic encryption. Community, you have to rely on explicit or manual encryption. I'll show you what that means in just a moment. But it's important to understand that the underlying crypto framework itself is open source and Apache licensed. So contrasting explicit encryption with automatic encryption, on the left, you see a simple insert, the code there, there's no encryption. So there are a couple of fields there that we really do want to encrypt. So when we're using explicit encryption, what you have to do as a developer is modify the code for any read-write queries. You have to include the encryption decryption logic. You've got to select the key and the appropriate encryption mode. If you contrast that with automatic encryption, you can see the difference between the left and the right. There is no difference, right? There's no of this code modification that you have to do. And how does it do that? Well, Ken referred to that during his section. It's done through JSON schema. So you can centrally define which fields to encrypt and the algorithms to use. So this is something that's available in MongoDB Atlas and MongoDB Enterprise. So the benefits of that, clearly higher productivity because there's no additional code for developers to write. And it improves data governance because application owners or InfoSec teams can centrally enforce the encryption of sensitive fields. They can mandate that. So, of course, there are questions that come up, frequently when we're talking to InfoSec teams and to developers. So we're going to run through those very, very quickly. The first question is, do I lose the ability to query encrypted data? And in short, no, you don't, as long as you're using deterministic encryption. And again, Ken referenced this in his section. So client-side FLE supports two modes of encryption, randomized and deterministic. So randomized will give a different value every time the data is encrypted, and that provides the strongest level of protection because it's defending against, very sophisticated frequency analysis attacks. But what it will do is prevent direct match or equality queries against those encrypted fields. Deterministic encryption, on the other hand, gives you the same value every time the data is encrypted. So you can do direct match queries on encrypted fields. You can still use indexes to provide very efficient data access. What it won't do is support more complex queries like range queries and aggregations and regexes, but it's very rare that you're encrypting every field of your document. So you would use those other fields that haven't been encrypted with client-side FLE to run those more advanced queries. What's the performance impact? Well, to the database server, it's very low because all encryption and decryption is happening, outside of that, or, in the drivers on the client, though some encrypted values will end up larger than their original plain text, but it's going to be pretty marginal. Where there will be a performance impact is in latency on the client, and the amount depends on how many fields you're encrypting. It can be a single-digit percentage for one or two fields. Apavita, who are a customer I'm going to talk about in just a moment, working in healthcare tech, were handling heavily encrypted fields on documents, on an application supporting tens of thousands of operations per second, and they saw a 10 to 15% overhead. But you know what? If your query is going from 8 seconds to 8 milliseconds, sorry, not 8 seconds, that wouldn't be great, but 8 milliseconds to just over 9 milliseconds, wall clock time, that's just not going to be perceptible to most users. So the overhead is low. And then the final question is, what's the provenance of client-side FLE, which is kind of a polite way of saying, how do we know we can trust this? Well, it's not something that we kind of knocked up over a weekend. Development started back in 2017, dozens of software and security engineers in MongoDB, but we didn't design this in isolation. We worked with some customers, some design partners. We also partnered with some leading crypto authorities from both industry and academia, including the IETF co-author of Authenticated AES and pioneers in encrypted search and crypto engineering. This was backed up by 6 months worth of user experience testing to make sure this feature really was usable. And it's been GA actually for a couple of years. And it's now in use by enterprises and governments operating in highly regulated industries. I'm going to give you a couple of quick examples of that. So we'll start with Apavita, who I mentioned a moment ago. They're serving over 2,500 hospitals in the US, over 2 million patients. They've been using MongoDB since 2013. They migrated to Atlas on AWS, so our fully managed cloud service, in 2018. But they found that 50% of their engineering cycles were being spent on securing new features, which is one of the reasons why they were so keen to work with us in the early stages of developing this feature. What they're able to do by implementing client-side FLE within the development shop is that they can add this capability in minutes. They can reinvest that saved engineering time in building new features. And by really leading with this feature in their own product offering, they've created, more industry-leading differentiation. And as their CTO at the time was actually publicly quoted as saying in articles in the press, is, he said, we've ended up with a nuclear launch code level of security. It works at scale, it works with the tools that developers understand, and it removes a huge layer of concern and management of security. Second example comes from somewhere a little bit closer to home for me, and that's in a European government agency. What this agency does is it manages state pension payments and working age benefits, and it does that for tens of millions of citizens in the country. They were facing a bit of a challenge because the government had mandated their move to the cloud to reduce costs and improve agility. But at the same time, they had a completely understandable policy that no unencrypted PII citizen data could ever leave their internal systems. And so what they did was they initially implemented application level encryption, and that added several months to the delivery of each new feature, not just in terms of extra code, that was a part of it, but also having to go through security reviews. And these reviews were conducted, every couple of months, and there was no way of accelerating those. So that really slowed things down. It reduced the database to a dumb object store. Their architecture team took a keen, hard look at client-side FLE, and that took a couple of months. But once they'd gone through that and they reviewed it, they approved it for use. That enabled the agency to move to MongoDB Atlas. It's accelerated delivery of new features by several months, and it's unlocked new functionality for citizens of that country. So some resources to learn more. There's a white paper that Ken and I have authored, and this will be available in the show notes as well on this the MongoDB.live platform. So here you can dig in a little bit more. And then we've got some real deep dive documentation into the implementation and reference of client-side FLE. and some full stack or guides for full stack developers showing you how you can add this to your applications in multiple programming languages. Well, that wraps up our talk on client-side FLE. I hope you found it useful. We wish you a great rest of the conference. Thanks for joining.